In this lesson, we're going to look at word problems that can be written as piecewise functions. Lisa makes $4 an hour babysitting before midnight and $6 an hour after midnight. She begins her job at 7 p.m. Write a piecewise function that specifies the amount she is paid on each hours. So for the first piece of this, she's making $4 an hour. So I'll do 4 times h. So if she works 1 hour, it's 4 times 1. If she works 2 hours, it's 4 times 2, which would be $8. If she works $3, 4 times 3, all the way until she hits midnight. And so from 7 p.m. to midnight is 5 hours. So this piece is defined for h between 0 and 5 hours. After 5 hours, she's making $6 an hour, but she still gets paid for those first 5 hours, and she makes $4 for the first 5 hours. So 4 times 5 is 20. So she'll make $20 for the first part of the night, and then after that, after midnight, she makes $6 an hour. But it's not going to be 6h because she was already paid for the first 5 hours. So you need to take h and subtract 5 because I've already been paid for 5 of the hours at the lower rate. And so if you check out this equation and see if it really works, for 5 hours then, 5 minus 5 is 0, times 6 is 0. So for 5 hours, she still makes $20. So it doesn't matter if I use the top equation if h is 5 or the bottom equation when h is 5. So I'm going to go ahead and put for h is greater than or equal to. If you want to just write greater than, you can, but you can have it equal in this one because at 5 hours, it doesn't matter which equation you use. And this is for 5 hours. Let's see if this really works. If I plug in 6 hours here, it'll be 6 minus 5, which is 1. So she'd make $6 for the hour after midnight, and then she'd make the first 5 hours $20. So it does make sense if you were to make a table and plug in values that these two equations work. On number 2, a certain country taxes the first $20,000 of an individual's income at a rate of 15%, and then all income over $20,000 is taxed at 20%. So write a piecewise function t that specifies the total taxes on an income of X dollars. So for the first 20,000, you're at 15%. So this is 15% times how much money you make. So if you make 5,000, 8,000, 10,000, whatever you make, you have to pay 15% of your first $20,000. So this is for X values that are between 0 and 20,000. And then after that, you're taxed anything above 20,000, you're taxed at 20%. So the first 20,000 you have to pay 15% on. If you take 0.15 and multiply that by the 20,000, that gives you 3,000. So for $20,000, you have to pay $3,000 in taxes. And then anything above the 20,000, you're now charged 20% on. And I've already paid on the first 20,000. So my X, I have to take out the first 20,000 because I've already paid the taxes on that with that 3,000. And then this is going to be good for X is greater than or equal to 20,000. And if you just want to have the greater than, that's fine. You can use either equation for the 20,000, but as long as one of them is covered, you're fine. On example 3, a lawn company charges $80 for the first 3 trips to cut your lawn. They then charge an additional $20 for each time they have to cut your lawn beyond the initial 3 cuts. Write a piecewise function to represent the cost per lawn cutting. Okay, so for this one, we have, which variable did they use? Did they say? They didn't, so we'll just use y. So for the first 3 cuts, they charge $80. It's a flat fee. Whether you get it cut once, they charge $80. Twice, it's the $80, or 3 times, it's $80. So for the first 3 cuts, it's $80. And that's for X values up to 3. After 3, so the 4th, the 5th, the 6th, they charge you $20. But you're going to already pay the first 3 cuts in the $80. Plus, it's $20 for each additional cut. So they give you a little bit of a break on the price if you get it cut more than 3 times. So it's 20 times X, but you have to subtract the first 3 cuts because you've already paid for those in the $80. So for 4 cuts, you do 4 minus 3, which would be 1 times 20, plus the first 3 cuts were $80. So that equation does make sense. And this is for X is greater than 3. If you want to put the equals, that's fine, because if X is 3 here, 3 minus 3 is 0 times 20, which is going to give you the 0. So it doesn't matter if you want to include the 3 there or not. For number 4, a grocery store charges $5 for a salad bar serving up to 12 ounces. Okay, so that's a flat fee. Sorry about the pop-up ad. So they charge a flat fee of $5, and that's up to 12 ounces. So that's X between 0 and 12. For each additional ounce, you have to pay 25 cents. But you're already paying for the first 12 ounces in that $5. So it'll be $5 plus it's 25 for everything above 12. So you have to do X minus 12 because you've already paid for the first 12 ounces. And then that's good for X values that are greater than 12. At 12, this equation still works though, because this will be 12 minus 12, which is 0 times 0.25. So I'm okay if you want to put the equals on that one too. Last one, we're just going to go back to a piecewise. And notice this is less than, so this will be the left side. This is greater than, that's going to be the right. So my break in this graph is going to be at X equals 2. So my left is Y equals -1/2